This is Sudhakar, Professor, EEE Department, St. Joseph College of Engineering. Today we are going to discuss the inverse discrete Fourier transform using FFT algorithm, 8 point. So, IDFT using DIT FFT. So, first in butterfly diagram, what is the difference between DIT DFT and DIT IDFT? So, in our previous video we have seen that DIT DFT using butterfly diagram. So, DIT is decimation in time. So, first stage we will have a 2-point FFT. This is stage 1. Before that the twiddle factor will be multiplied. Next one we have 4-point FFT, twiddle factor W8 power 0 and W8 power 0, and finally we will have 8-point FFT. So, here we will have 4 twiddle factors W8 power 0, W8 power 1, W8 power 2, W8 power 3. So, this is what we will have in our DIT. Finally, input is x of n in time domain, output is x of k in frequency domain. So, inverse means just inverse, that is my input will be in frequency domain x of k and output will be in x of n in between. So, as it is inverse, all the processes are also inversed. This basic difference is drawn, then we can easily draw the diagram. So, here x of k closer to 1 is that we will have a 8-point FFT. And next what we have? We have the twiddle factor. So, if you twiddle factor, that is W8 power 0, W8 power 1, W8 power 2, W8 power 3. Here it is forward. Since we are getting inverse here, I am putting a minus sign here. So, that is the difference here. Next one is 4-point FFT. Here also the twiddle factor will be there. W8 power, here also minus 0, here also minus 2. And last stage is the 2-point FFT, twiddle factor W8 power minus 0, and final answer will be x of n. Okay. So, difference is first here it is 2-point, 4-point, 8-point, here 8-point, 4-point, 2-point, and in the next stage twiddle factor is before this FFT. Here the twiddle factor will be after the FFT, and here it is power is positive, here the power is negative. So, if you calculate the twiddle factors, here we will have W8 power 0 is 1, here W8 power 0 is 1, W8 square is minus j, W8 power 0 is 1, W8 power 1 is 0.707 minus j 0.707, W8 power 2 is minus j, W8 power 3 is minus 0.707 minus j 0.707. So, this is the twiddle factors we have calculated earlier. Here since minus sign is incorporated, we will have sign change in these values, that is W8 power minus 0 is 1, W8 power minus 1 is 0.707 plus j 0.707, W8 power minus 2 is j, W8 power minus 3 is minus 0.707 plus j 0.707, W8 power minus 0 is 1, W8 power minus 2 is j, W8 power minus 0 is 1. So, these are all the difference. So, once we know that butterfly diagram there, easily we can solve this butterfly diagram. Okay. So, values will change here. Here minus, instead of minus j, we will have plus j. Here minus j, it will be plus j. Simply you can remember all the minus j in DFT will be changed to plus j in IDFT. So, this is the basic concept here. So, using this concept, we are going to solve a problem for IDFT. So, we will take the same problem which we have solved in the earlier video, that is we found out DFT for a sequence. So, for which what sequence? DFT of x of n, DFT of x of n 1, 1, 1, 1, so that we can cross check whether what we have obtained in this previous session is right or wrong. So using this, we have obtained x of k using DIT FFT method. We have obtained an answer 4 1 minus j 2.414 0 1 minus j 0.414 0 1 plus j 0.14 0 1 plus j 2.414. So this sequence I am going to take it and see that such that the reverse process I am going to get the answer. So like this it is DFT, if it is going like this it is IDFT. So same problem I am going to apply and find out whether the answer obtained is going to be right or wrong. So same butterfly diagram. So it's also DIT, everywhere it is DIT only. So if diff is there, the procedure will also differ. So here also DIT FFT, only 8 point. Here also it is 8 point. So we will draw the diagram there. So start from here. First procedure, we have to draw 8 parallel lines. Since it's 8 point, we are drawing 8 parallel lines. If it is 4 point, we will be drawing 4 parallel lines and 3 stages will be there. The difference, one more difference between IDFT and DFT is initially the calculation will be simple there, here little bit complicated. So decimation in frequency. So my input will be of correct order, x of 0, capital X, x of 1, x of 2, x of 3, x of 4, x of 5, x of 6 and x of 7. So since it's frequency, no shuffling, x of 0 first value, this is 0, 1, 2, 3, 4, 5, 6 and 7. So x of 0 is 4, x of 1 is 1 minus j 2.414, x of 2 is 0, x of 3 is 1 minus j 0.414, x of 4 is 0, x of 5 is 1 plus j 0.414, x of 6 is 0, x of 7 is 1 plus j 2.414. So we can finish the diagram first. First stage is 8 point. So 8 point starting from first and fifth line, second and sixth line, third and seventh line, fourth and eighth line. Now reverse process from 5 to 1, 6 to 2, 7 to 3 and 4 to 8 to 4. 4 minus 1 will be there. Twiddle factor will be afterwards. So leave some space for initial calculation. So twiddle factor here is W8 power minus 0, 1. W8 power minus 1 is 0.707 plus j 0.707. W8 power minus 2 is j. W8 power minus 3 is 0.707 plus, minus 0.007 plus j 0.707. Some more space we will leave it. From here we will draw the next stage. This is stage 1, 8 point FFT. This is stage 2, 4 point FFT. So 1 to 3, 2 to 4, 3 to 1, 4 to 2, 5 to 7, 6 to 8, 7 to 5, 8 to 6. 2 minus 1 sign here. twiddle factor W8 power 0, W8 minus 0, W8 power minus 2, W8 power minus 0, W8 power minus 2. And the last stage, single point, sorry, 2 point, stage 3, 2 point FFT. So, here also minus 1 will be there. Twiddle factor W8 power minus 0, it is going to be 1 only. So, no issues, right. So, this is the basic diagram here. This is stage 3, 2 point FFT. So, why your previous diagram and this diagram, if you compare, the intermediate space will be larger because the more calculation is involved, as I said earlier. So, this is the basic diagram. So, all the values you know, W8 power minus 0 is 1, this is J, here everything are 1, anything power 0 is 1, either plus 0 or minus 0. So, it is going to be 1 there. So, we will go now. So, all the values you have already written there, it is frequency, so no shuffling here, output answer will be shuffled here. So, what is the answer here? X of 0 first value, this one is x of 4, x of 0, sorry, x of 2, x of 6, x of 1, sorry, this is correct, I will check it, x of 0, 0, 1, 4 only, correct. So, x of 5, x of 3, x of 7. Okay. Why this is shuffled here? Because we are using DIT method here, decimation in time, shuffling in time period. Okay. So, now we will go here. So, same method calculation. So, we know the diagram now. So, two things here, two signals A, B, capital A, capital B here, minus 1. So, this side here it is W8 power 0. So, capital A equal to A plus B, capital B equal to A minus B, whole thing W8 power 0. Earlier method we add only B into W8 power 0. Okay. Whereas in this it is we have to, so that is why a space is given there, next the twiddle factor value is there. So, that is the reason of why I have given space before and after the twiddle factor. So, first signal here this one is 4, second signal if you track the diagram it is 0. So, 4 plus 0 equal to 4. Second one 1 minus J 2.414, this is the signal here, and by tracking the next signal is plus here. So, plus 1 plus J 0.414 equal to 2 minus J2. Okay, because it is minus J2 4.114 plus J 0.414. So, you can directly add it, you will be getting the answer minus 2 here. Okay. Next signal if you come here, this signal x of 2 is 0. So, first signal is 0, when you backtrack it this next signal is also 0. So, 0 plus 0 it is 0. Next we come to the third signal. So, x of 3 first value is 1 minus J 0.414. Next value is here plus 1 plus J 2.414. So, if I multiply this also what I will get, plus and 1 plus 1 it is 2, again here same value. So, plus J 2. So, there I had 2 minus J 2, here I have here 2 plus J 2. Okay. Next one here, this signal, first signal is 4, next is 0 into minus 1, so 4 minus 0, it is 4. Next one, when I come to this, the first signal is 1 minus j 2414 minus 1 into 1 plus j 0.414. Okay. So, if I transfer this minus sign here, so it will become minus 1, plus 1 and minus 1 will get cancelled here. Here also it will come as minus 1. So, it is I have to add these two signals, minus j 2.828. Okay. This is the value here. Next one, when I come to this signal, the first signal is 0, minus 0, it is 0. Okay. Again, when we come here, it is first signal is 1 minus j 0.414 minus 1 plus j 2.414. When I bring in this minus sign inside, plus 1 and minus 1 will get cancelled here. Here it will become minus j. So, minus j 2.828. All these values before twiddle factor value, multiplication with twiddle factor. Now, we have to, if twiddle factor is available, we have to multiply with twiddle factor. If twiddle factor is not available, then we can no need to multiply. So, for the first 4 signals, there is no twiddle factor. So, I can directly write those values there. So, here it is 4. First signal, it is 4. Second signal, 2 minus j2. Third signal, 0. Fourth signal, 2 plus j2. Okay. These signals I directly write. Next one, 4. 4 into 1 here. Because the twiddle factor value is 1, so my value is here is 4. Okay. Next one, finally, this here, this signal is minus j 2.828 into 0.707 plus j 0.707. So, we will multiply with calculator. J minus j into 2.828 into 0.707 plus 0.707 j. So, we will get here 2, answer is equal to 2 minus 2j. Okay. Next one, 0 into j, anything 0. Last one, again minus j 2828 into minus 0.707 plus j 0.707. So, equal to, so you put in the calculator minus j to 8.88 so here we will have 2 plus 2j. So, this is the value here. Okay. And next we have to come to this stage 2. This up to this, the stage 1 is covered. Next we are going to stage 2, right. So, here first value is 4, second value is 0. So, 4 plus 0, it is 4. Next one, this signal 2 minus j2, next signal is plus 2 plus j2. So, these two signals will cancel, we will have 4. Here 4 minus 0 equal to 4. Here 2 minus j2 minus 2 plus j2. So, minus, and if I get inside, plus 2 and minus 2 will get cancelled here, here minus. So, answer is minus j4. Okay. So, next one here, staged second part of 4 point FFT, 4 plus 0 is 4. Here 2 minus 2j plus here plus 2 plus 2j. These two things will get cancelled here, I will have 4. Okay. And next this one 4 minus 0 4 here again 2 minus 2j minus 2 minus 2 plus 2j. When I bring in minus sign here, 2 and minus 2 will get cancelled and here this will become, so I will have minus 4j. So now again we have to multiply. If twiddle factor is there, we have to multiply with the twiddle factor. So here first part 2 signals, no twiddle factor. So 4 plus 4. Okay. Next here 4 into 1. So my answer is 4. Here minus 4j into j. J into j is minus 1. So minus 1 into minus it become plus. So my answer is 4. Okay. So here no twiddle factor, 4 4. 4 into 1 is 4. Here 4. Here 4 minus 4j into j. So j into j is minus 1. So minus minus we will have here 4. Okay. So next we come to this last point. Okay. So 4 plus here 4 plus 4 is 8. 4 minus 4 equal to 0. 4 plus 4 is 8. 4 minus 4 is 0. 4 plus 4 is 8. 4 minus 4 is 0. 4 plus 8 is, 4 plus 4 is 8. 4 minus 4 equal to 0. Twiddle factor is 1 only. So after twiddle factor also 8, 8, 8, 8. One more last one point we have to add here, that is divide by. My x of 0 value should be divided, the output signal must be divided. It will be, by standard notation is 1 by n, where n is the number of point. Here we have it's 8 point, so I have to divide by 1 by 8. Okay, 0 no. So 0 here 8 only. Okay. So 1 by 8. So everything, one arrow should be there, 1 by 8. One arrow, 1 by 8. One arrow, 1 by 8. One arrow, 1 by 8. You put an arrow, below that you write 1 by 8. All this process you would have studied in signals and systems. These notations we would have studied in signals. So 8 into 1 by 8, that's the meaning. That is 8 into 1 by 8 is 1. 0 into 1 by 8 is 0. 8 into 1 by 8 is 1. 0 into 1 by 8 is 0. 8 into 1 by 8 1. 0 into 1 by 8 is 0. 1 0. So now this stage we can't write the answer directly like this. We have to write the final answer here, x of n. My final answer should be there. It should be written in the order. So first signal is for n equal to 0. So n equal to 0, x of 0 is 1. So I have to write the first one here. Okay. Next one, x of 1. X of 1 is here. X of 1 is 1 here. Okay. Next one, x of 2. X of 2 is here. So x of 2 value is 1. X of 3 now. X of 3 is here. X of 3 value is 1. Next one, x of 4. X of 4 is here, that is 0. X of 5. X of 5 is here, 0. X of 6 is here, 0. And finally x of 7 is here, that value is also 0. So this is the given data. Last video we started here, x of n. Okay. So we have started with x of n and we obtained this. This is the given problem. So this one we have seen in the previous video. For x of n we have obtained x of k. Now using the same x of k as input, we have brought back this answer x of n. So this is the IDFT, inverse discrete Fourier transform, using 8-point, okay, using 8-point DIT FFT. Okay, I hope this procedure will be very clear. Thank you very much.